We have a non-right angle triangle here with sides shown and angle given. And we're asked to show that the length BC, which we're calling P, satisfies this equation. So we can use the cosine rule here. C squared is A squared plus B squared minus 2AB cos C. This is always the version I use. There are two other versions of it. As long as you choose one of them and apply it carefully, you're fine. And it doesn't matter that they've labeled it A, B, and C. I can just change it. I can say I'm going to call that capital C, so this is my little c, and then B can stay as it is, so this is little b. Now this needs to be capital A and little a. So I've got P squared is going to equal 4 plus H squared plus 4 minus H squared minus 2 times 4 plus H times 4 minus H times cos 60. You can put this one in your calculator, it's actually going to be a half. And the 2 and the half cancel out. Now I'm going to expand the double brackets. So 4 plus H all squared is 4 plus H times 4 plus H. I'm going to get H squared plus 8H plus 16. And then over here, I'm going to get H squared minus 8H plus 16. So the 8H's cancel. And then I'm minusing. Okay, this is actually going to become a difference of two squares. It's going to be 16 minus H squared. Note, I put it in a bracket because I'm minusing the whole thing. I'm going to need to deal with that in a minute. So I'll just simplify the top line. So 2H squared plus 32. And then I'm going to minus 16 and add H squared, which gives us our required result. P squared is going to be 16 when these partially cancel, plus 3H squared. Nice. Hence show when H is small that P will approximately equal this. Well, we have P squared, so it must be that P is going to equal the positive square root of 16 plus 3H squared. But what it seems to be referring to is an expansion. So I'm not going to write it as a square root. In fact, I'm going to write it as to the power of a half. And we need to do a binomial expansion. So the formula book gives this formula when we have something in the form 1 plus x to the n. Now we don't have that at the moment, so there's an extra little step needed. I need to factorize out 16 from the whole thing. It's going to become 1 plus 3 over 16h, and all of that is raised to the power of a half. Now I can just raise 16 to the power of a half and times it by 1 plus 3 over 16h to the half, which becomes 4. 1 plus 3 over 16h to the half. Okay, I'm ready. I'm just going to keep the 4 there and then deal with the rest of it. So I've got my 1, and this becomes, wait, I lost a squared along the way. Sorry about that. Okay, I've regained it. That's going to be my x, and that's going to be my n, the half. So carefully do this. Actually, I've already made a mistake. So it's going to be 1 plus a half, 3 over 16h squared, plus a half times a half minus 1. Sometimes people like to write a half minus 1. I just find it easier to just figure it out as we go. But use your calculator as needed. Divided by 2 factorial, that's just divided by 2. And then 3 over 16h squared squared. And there's going to be more terms, but let's just take a little glance at the answer. The last term they've written is h to the 4, and that's what I've got here. So I'm going to stop there. Okay, let's tidy this up. I actually think it's best to multiply through by the 4 as we go. So 4 times 1, 4 times a half is going to give us 2 times 3 over 16h squared. Otherwise, I'm going to multiply these fractions and then times by 4. I think this is a good way to do it. Okay, and then the next one is going to, well, I've got a 4 And actually that's going to cancel with this half and this half. So I'm just going to end up with minus a half 3 over 16 h squared, plus some more terms, of course. So I'm going to do 2 divided by 16 to get, that's going to give 1 over 8. So I'm going to get plus 3 over 8 h squared. And then over here, all right, this one probably calls for a calculator. So 3 over 16 squared, that's going to be 9. I've squared that bit myself, over 16 squared. And then I'm going to be dividing by 2. So we can actually times by 2 on the bottom, same thing. So 9 over 512, just remember it's minus that. Okay, and therefore for small h, this is an infinite expansion, but for small h, p is therefore going to approximately equal these 3 terms. You can write down that lambda is 3 over 8 and mu is going to be minus 9 over 512, but it just says to determine them, and I have determined them, so I'm going to leave it like this. Well done.